Imagine looking into the night sky and realizing that one distant point of light may hold clues to one of humanity's oldest questions. Are we alone in the universe? For centuries, that question belonged to philosophy and imagination. Today, it belongs to science. Thanks to powerful observatories like the James Webb Space Telescope, astronomers can now study the atmospheres of planets orbiting distant stars, searching for the chemical fingerprints that might reveal whether life exists beyond Earth. Among all the worlds discovered so far, one has attracted extraordinary attention. Its name is K2-18b. Located about 120 light-years away in the constellation Leo, K2-18b circles a cool red dwarf star. Although that sounds unimaginably far away, it is close enough for today's most advanced telescopes to examine its atmosphere in remarkable detail. What makes this planet so fascinating is that it doesn't resemble any world in our own solar system. K2-18b is classified as a sub-Neptune, a planet larger than Earth but much smaller than Neptune. It belongs to a category that scientists are only beginning to understand. These planets appear to occupy the space between rocky terrestrial worlds and giant gas planets, making them unlike anything orbiting our Sun. Because of this, astronomers cannot simply compare K2-18b to Earth or Mars. Instead, they must build entirely new models to understand what such a planet might actually be like. Even more intriguing is its location. K2-18b travels through the habitable zone of its star, the region where temperatures could allow liquid water to exist under suitable atmospheric conditions. Although its star is much cooler than our Sun, the planet receives enough energy that scientists believe water could remain stable beneath its thick atmosphere. That possibility immediately captured worldwide attention. The James Webb Space Telescope investigated K2-18b using an extraordinary method known as transit spectroscopy. Whenever the planet passes in front of its star, a tiny amount of starlight filters through its atmosphere before reaching Webb. Different gases absorb different colors of light, allowing astronomers to identify the atmosphere's chemical ingredients without ever leaving Earth. The results were remarkable. Webb detected strong evidence for water vapor, methane, and carbon dioxide. None of these molecules proves that life exists. However, together they describe an atmosphere unlike any previously observed around a potentially habitable exoplanet. The discovery encouraged scientists to consider an exciting possibility. Rather than being a dry rocky planet, K2-18b may be covered by an enormous global ocean hidden beneath a thick hydrogen-rich atmosphere. If that idea is correct, K2-18b could belong to an entirely new family of planets known as Hycean worlds. This concept is changing how researchers think about life beyond Earth. For decades, the search focused almost exclusively on planets that look like Earth. But nature rarely follows human expectations. Life, if it exists elsewhere, may thrive on worlds that appear completely unfamiliar. The discovery of K2-18b reminds us that the universe may contain countless environments capable of supporting biology in forms we have never imagined. And this is only the beginning. As scientists continue studying this extraordinary planet, even more surprising clues are beginning to emerge. Clues that could completely reshape our understanding of where life can exist in the cosmos. As exciting as the discovery of water vapor, methane, and carbon dioxide was, another possible finding captured even greater attention. During its observations, the James Webb Space Telescope detected a faint signal that may point to the presence of a molecule called dimethyl sulfide, or DMS. On Earth, DMS is produced mainly by microscopic marine organisms living in the oceans. Because of that, astronomers consider it a potential biosignature, a chemical that could, under the right circumstances, hint at biological activity. But this is where science becomes both exciting and careful. Researchers have not confirmed that DMS is truly present on K2-18b. The signal remains weak, and additional observations are required before scientists can determine whether the molecule is actually there or whether another natural process created a similar spectral pattern. This cautious approach is essential. Throughout the history of astronomy, many extraordinary discoveries have first appeared mysterious before eventually receiving perfectly natural explanations. Every new observation must survive careful testing, independent analysis, and repeated confirmation before becoming accepted scientific evidence. Even if future studies show that DMS is absent, K2-18b will remain one of the most fascinating planets ever discovered. Its atmosphere is already teaching astronomers that potentially habitable environments may exist on planets very different from Earth. One of the most exciting ideas connected with K2-18b is the possibility that it belongs to a class of planets known as Hycean worlds. Unlike Earth, which has continents, shallow oceans, and a nitrogen-rich atmosphere, a Hycean planet may be covered almost entirely by a deep global ocean hidden beneath a thick blanket of hydrogen gas. That atmosphere could trap heat efficiently, allowing liquid water to remain stable even under conditions very different from those on our own planet. If such environments are common throughout the Milky Way, the number of potentially habitable worlds could be far greater than scientists once believed. Life in those oceans, if it exists, would almost certainly be microscopic rather than advanced. Yet Earth itself demonstrates that microscopic organisms can survive in some of the harshest environments imaginable. Deep beneath the ocean floor, around volcanic hydrothermal vents, and beneath kilometers of Antarctic ice, tiny organisms continue thriving under conditions once thought impossible for life. Those discoveries remind scientists to keep an open mind when studying distant planets. The search for life is no longer limited to finding another Earth. Instead, researchers are exploring an incredible diversity of worlds, each with its own unique chemistry, climate, and history. Future observations by the James Webb Space Telescope will examine K2-18b again with greater sensitivity, searching for additional atmospheric molecules and improving the accuracy of existing measurements. At the same time, next-generation observatories will expand this search to hundreds of similar planets orbiting nearby stars. Every new spectrum collected, every atmospheric measurement, and every refined computer model brings astronomers closer to answering one of humanity's greatest questions. Is life unique to Earth, or has nature repeated the same miracle across countless worlds throughout our galaxy? Today, no telescope can provide a final answer. But K2-18b has already accomplished something remarkable. It has expanded our imagination, challenged long-held assumptions, and reminded us that the universe is far more diverse than we once believed. Somewhere beneath the clouds of that distant world, an immense ocean may have existed for millions of years, completely unaware that a civilization on a tiny blue planet has only just begun searching for it. Whether K2-18b ultimately proves to be lifeless or becomes humanity's first compelling evidence of biology beyond Earth, its story has only just begun. And with every new observation, we move one step closer to understanding our place in a universe filled with possibilities.